many requests for analysis training for Excel among my students. I'm about to give you a very fast uh, analysis training of the correlation coefficient. So there are four things that you have to understand in correlation. I'm going to put them here. First is the magnitude. All right. Next, oh sorry. First is the magnitude of the relationship. Two is the direction. Don't bind the numbers on the left because it's randomized. Third is the significance. And then the fourth is the determination. Alright, so I have here totally random two arrays of random numbers. Okay. And we're going to calculate the correlation coefficient, and we'll apply what I'm telling you here. So first is you do it. You get the correlation coefficient. Of course, in SPSS is pretty much automatic, but here in Excel you have to do it the long and the hard way. Okay, not pretty hard, right? But okay, so we have here a very small number, 0.01, due to the fact that I just gave random numbers. So this is the correlation coefficient, and you call it R, right? And then what you have here is the coefficient of correlation or coefficient of relationship. The coefficient of correlation goes from -1 to +1, right? So you have also, oh sorry, also okay, it doesn't accept that. Okay, so anyway, -1 to +1. Now, if you will disregard the sign, then the numbers would lie between 0 and 1. 0 meaning no relationship, and 1 meaning perfect relationship. As it is in love and life, there is no 0 and there's no perfect 1. Alright, so magnitude refers to the degree of the relationship, the degree of the coefficient of correlation. So we are using this scale. So from 0 to 0.2, okay, and then from 0.21 to 0.4, 0.41 to 0.6, 0.61 to 0.8, 0.81 to 1. Alright, so from 0 to 0.2, this is practically 0, right? But we call it very low or very weak relationship. 0.21 to 0.4 is low or weak relationship. 0.41 to 0.6 is moderate. 0.61 to 0.8 is high, while 0.81 to 1 is very high. So this is pretty much what you will put in the magnitude. Now in the direction, you will just put either positive or negative. So in this case, we have here a positive but very low or very weak positive relationship. Now for the significance, this I cannot compute here in Excel, or I don't know yet if there is a thing that you can do in order to get the significance in Excel, but in the SPSS output, this is the one that is being signified by the p-value or the sig value, the one with the sig value. So sig means significance, and you have to, the cutoff is around 0.05. So for social sciences, if your p-value is less than 0.05, then it is significant. So without looking at the table of values, this kind of R is not significant because it has a very low relationship. So the last one is the coefficient of determination. The coefficient of determination is merely R square. Okay, R square is just the square of your R over here. So if you have the R at 0.01, you just have to square it. So just multiply it by itself or raise to 2. Okay, so this is your R square, which is 0.000192, or if you convert this to percent, uh, this will be, this will be 0. Sorry about that, 0.02%. So practically, what it tells you is the percent of the variance of the dependent variable being explained by the variance of the independent variable. So if you are comparing these two arrays, what this R square is saying is that you can actually predict the value of the dependent variable, whichever is the dependent variable here, but the degree of prediction is only 0.02%. That's the only percentage of the variance that can be predicted. The 99.98% is predicted by other variables other than this one. So it's pretty much saying that these two variables, these two sets of numbers, are not related at all. Okay, so that's how you analyze your correlation coefficient. Bye for now.